So this is the third part of 6.2. The third part of 6.2 is to verify whether or not two functions are inverses. And unlike what we did on Wednesday, we're not actually going to find the inverse. There's a way to determine if two functions are inverses, and we're going to go through all those steps right now. And it goes back to what we did in 6.1, where we found f of g of x and g of f of x. We're going to be doing that a lot. So if you were good at that and you felt comfortable with that, this isn't going to be too bad, okay? But if you struggled with that or you didn't do it, that's something you're really going to have to get caught up on. So here's what we're looking at. We're going to verify that functions are inverses. And I'm going to list a whole bunch of steps on this page so that when you go to do your homework later on, you have sort of a reference guide so you know what you're supposed to do at each step. Ultimately, if two functions are inverses, this has to be true. Okay, so I definitely want you to write this down. So I have these two functions, f of x, g of x. They are inverses if and only if. And remember that this is, if you want to write it with just parentheses, I'll write it down here. F of g of x, and this means g of f of x. Slide them up, okay. Those mean the same thing. So if both of those equal x, if when you do f of g of x, it equals x, and you do g of f of x and it equals x, then f and g are inverses of each other. If that doesn't happen, they aren't inverses. When we do this verification or determination, you're going to be finding f of g of x, you're going to be finding g of f of x, just like we did in 6.1, okay? And that's the work that you're going to have to show. Just so you know, in the book, it talks about graphing and we're not doing any graphing for this, okay? We're going to ignore all of that part. What I'm going to show you today is the work that you're going to need to show, okay? All right, so step one is you're going to start by finding f of g of x. Then what that equals determines what we do next. So there's going to be different scenarios, right? If f of g of x does equal x, then you go on and find g of f of x. And then the next steps are going to be if it doesn't equal x, okay? So we're going to have this is going to be kind of the steps that you're going to follow. So if this ends up happening, and this is true, then you go on and find g of f of x. So if it equals x, then we go on and find g of f of x. If it doesn't equal x, so it equals something else, and we're going to go through some examples today, then they can't be inverses. F and g cannot be inverses, you just stop. You're done, and you say, it doesn't equal x, they're not inverses, next problem, okay? Okay, now, so this is really more like 1A would then you would jump down to C, okay? So if 1A is true, you jump down to C, because you had to find g of f of x. If then g of f of x also equals x, then f and g are inverses. Okay? So that's going to be the proof. To decide if those two functions are inverses, you'll show that f of g of x equals x, and then you'll show that g of f of x equals x, and then we know that they're inverses. Okay? Okay? It is possible, but very unlikely, that you go from A to C, but it is also possible to go from A to D. That you find f of g of x and it equals x, and then g of f of x doesn't equal x. That's going to be rare, but again, they both have to equal x in order to be inverses. That's A and C. Okay? D saying A is true, but D is not true. So g of f of x doesn't equal x. So again, the idea being, they both have to equal x to be inverses. If one of them does not equal x, then there can't be inverses. So we're going to go through two examples. One of them is going to be where f and g are inverses, and the other one's going to be when they aren't. Okay? The first one, and if you want to take a picture of this screen, you can. If you want to write it down, you can. But we're going to do a little bit of analysis before we start doing anything. Okay. So let's do a little bit of analysis. Remember, inverse kind of means opposite. So we're looking to see, before we even start, if there's a chance that these could be inverses. And we want to look for opposite things going on. So notice here in F, I have 3 times x. In G, I have 1/3 x. So those are kind of opposite. I have a minus, I have a plus. So those are opposite as well. At this point, it seems kind of promising, like that they might be inverses. There's enough going on that's similar and opposite that maybe they could be inverses. So my first move is to find f of g of x. So go ahead and find f of g of x. So if you remember, what this means is we're taking the entire function g and we're putting it into f. So what that means in this problem is all of this, which is g, is going into everywhere there's an x in f. Okay? So you're just going to replace this x with 1/3 x plus 4 and then simplify it out and see what you get. Okay? So the whole thing has to get put in place. So it's going to look like this. Okay? So all of this goes in place of x in f. So notice what I have here. This is really 3x minus 3. But my x input is the other function. Okay, so now you got to simplify this down and see if it equals x. If it equals x, then we go on and we find g of f of x. If it doesn't equal x, we stop and say they're not inverses. Okay? Distribute. What is 3 times 1/3?
1x.
1x. What is 3 times 4?
12.
Okay, so here's where I'm at right now. 1x or x. Then I can combine 12 minus 3, which is 9. Okay, and that's as far as I can go. And I saw a lot of you had that. So, does it equal x?
No.
So when you get down all the way to the end and simplify, and that's as far as you can go, if it doesn't equal x, then that means f and g can't be inverses. So then you have one more step, and that's to write, because it asks, determine which are inverses and explain your reasoning. Well, my reasoning is f of g of x doesn't equal x. So they can't be inverses. This is what I want you to write. And I just copy and pasted this from the notes part on the other slide. So you can copy and paste from your own notes and put that as your explanation. Okay? I think that was 1b. I know it was 1b. Okay. And then you stop. You don't need to go on and find g of f of x. There's no reason to. There's no way that they can be inverses already because of the fact that it doesn't equal x. Okay? Any questions before we move on to the next example? Okay, so obviously we have one that wasn't, so the next example, they are going to be inverses. Okay, so there's going to be a lot more work to do when there are inverses, because I then would have to keep going on this and find g of f of x. So here's the next example. I've got f of x equals negative 2x plus 2. Then I have g of x equals negative 1/2 x plus 1. Okay, so again, we've got some similarities and opposites going on. All right, negative 2, negative 1/2. They're both plus, so instead of the plus minus thing like we had in the other one, so, and the numbers are still different. So I'm a little more skeptical about this one, but we'll see. Okay, first step, what is the first step?
Plug in negative 1/2 x plus 1 into x.
More generally speaking, what are we finding? You're correct. F of g of x, correct. Okay, so find f of g of x, do that. So we're going to find f of g of x the exact same way we found it in the previous problem. So g goes into x in f. So now, here's what it looks like, right? I take g and I put it into x in the other one, so this is just a big X. Distribute, negative times a negative. That's going to be positive 1x or just x. And then negative 2 times plus 1 is negative 2. So here's where I'm at. Okay, x minus 2 plus 2, well, minus 2 plus 2, those cancel out. So f of g of x equals x. Now some of you had 1x, and that's fine, that's the same thing. okay? So now, since f of g of x does equal x, I have to keep going, right? Now I have to find g of f of x.
You meant that, oh, never mind.
So now,
Yeah.
Will be the same as.
That's what I thought.
not same as each other, it'll just equal x. It will equal x. So now, find g of f of x, and hopefully it should end up having the same situation. Obviously now, instead of putting g into f, we're taking f and putting it into g. Okay? So plug that in, and it should also equal x if we do everything correctly. Again, most of the time, when the first one's true, the second one's going to be true. Take a look. I plug. Again, I just plug minus 2x plus 2 in for x in g. I distribute negative times the negative. That gives me positive 1x, or positive x. Negative 1/2 times positive 2 is negative 1. So here's where I'm at. The minus 1 plus 1 kills. So g of f of x also equals x. So what that tells us is f and g are inverses. So for your explanation, you should have something like this. What Peyton said was good. Okay, here's how I did it. Okay. Because both f of g of x equals x and g of f of x equals x, f of x and g of x are inverses. Okay? And that would be your final step. In fact, most of the time, the directions will say explain your reasoning. They should. I will tell you that if for some reason it doesn't, you should still explain. Again, what you're doing here is you're making an argument, right? You're providing the evidence, and then you're making a conclusion. So this is all the justification for your conclusion. Right? All this evidence is the justification, or the reasoning behind why you make whatever conclusion you make. Okay? So that's the rest of 6.2. Now, in your homework, you're going to revisit the first day. So the first few problems are like what you did on day 1. And then the last 4 problems are like this. Okay? And we will look at all of that again on Tuesday. So that you do have homework over the 3-day weekend.